When you talk to an AI, it doesn't read your words the way you do. Before anything happens, your text gets chopped into small pieces called tokens. Tokens are what the model actually reads and writes. So let's see what they really are. Computers don't read letters the way we do. Before an LLM can do anything with your text, the text is chopped into small pieces called tokens. A token is just a chunk of text, the basic building block the model reads and writes. Every input you type gets turned into tokens going in, and the model produces tokens coming out, which are then stitched back into readable text. Tokens are the alphabet of the machine, except the letters are chunks. Here's the part that surprises people. A token usually isn't a whole word. Common short words like cat or the are often a single token. But longer or rarer words get split into pieces. Unbelievable might become un, believe, and able. Even spaces and punctuation can be their own tokens. So a token can be a word, part of a word, a single character, or a symbol. The model learned a fixed menu of these chunks during training, and it only ever works with items from that menu. Why not just use whole words? Because language is messy and endless. New words appear all the time. People make typos, there are names, emojis, code, and dozens of languages. If the model only knew whole words, anything unfamiliar would break it. By keeping a menu of reusable chunks, it can build almost any word, even one it has never seen, by snapping pieces together. It's flexible, efficient, and it never hits a word it simply can't represent. How big is a token? For English, a handy rule. One token is about 4 characters, or roughly 3/4 of a word. So 100 tokens is about 75 words, a short paragraph. It's only an estimate, but it's good enough to reason about size. Here's something important if you don't work only in English. Tokenization depends on the language. English text is usually very token efficient because the model saw so much of it during training. Other languages, including Greek, often get split into many more smaller tokens for the exact same meaning. The same sentence can cost noticeably more tokens in one language than another. That has real consequences, which brings us to why any of this matters to you. Every model has a limit on how many tokens it can handle at once, its context window. Your prompt, the conversation history, and the model's reply all share that budget. When it fills up, the oldest tokens fall out, which is exactly why a long chat starts to forget how it began. So how much can it remember really means how many tokens fit. Tokens are also the unit of cost and speed. When you use these models through an API, you're billed per token, in and out. And the model generates 1 token at a time, so longer answers literally take more steps. Shorter, tighter prompts aren't just cleaner, they're cheaper and faster. This also explains a classic glitch. Ask a model how many R's are in strawberry, and it sometimes gets it wrong. Why? It doesn't see 10 separate letters, it sees a couple of tokens. It's reading in chunks, not characters, so letter-level puzzles aren't its natural strength. Knowing this, you'll understand why it stumbles instead of being surprised by it. So, a token is the small chunk of text an LLM actually reads and writes. Words are for us. Tokens are for the model. Next episode, the thing you control most, the prompt. See you there!